This is fluorescein. Well, actually, only 0.000001% of this is fluorescein. You see, fluorescein is an extremely fluorescent organic dye commonly used in medical imaging due to its very low toxicity, and just 1 milligram of this stuff is able to make a whole liter of water fluoresce brightly. This is pretty fascinating in my opinion, so I decided to start an 8-part series on the synthesis of fluorescein, starting from simple old aspirin. I'm going to be starting with aspirin, which is chemically known as acetylsalicylic acid, hydrolyzing it to form salicylic acid, and then decarboxylating the salicylic acid to form phenol. The phenol will then be meticulously metanitrated and then reduced to make 3-aminophenol. The aminophenol is going to be converted to resorcinol, which will then be reacted with phthalic anhydride to form our final fluorescein. This is part 1 of the series, and in this video I'm going to be doing the first step, which is hydrolyzing the aspirin into salicylic acid. First, we're going to need some pure aspirin. If you only have access to aspirin tablets, you can extract the acetylsalicylic acid from the tablets by grinding them and mixing them with hot ethanol. Then filter off the insoluble stuff and cool the ethanol down to allow acetylsalicylic acid to crystallize. I was able to have access to pure aspirin online, so I don't need to do this step. So, let's begin with the synthesis. I first added 50 grams of acetylsalicylic acid to a large round bottom flask, followed by 700 ml of distilled water and 15 ml of concentrated hydrochloric acid. I then add a condenser on top of the flask and turn on my heating mantle. Once the water starts boiling, all of the aspirin is going to dissolve. The reaction is an acid-catalyzed ester hydrolysis. This is what's going on. The hydrochloric acid dissociates into hydrogen and chloride ions. The hydrogen ions combine with water molecules to form hydronium ions, H3O. The hydronium ions then catalyze the hydrolysis of aspirin, breaking the ester bond and forming salicylic acid and acetic acid. The formation of acetic acid is why the mixture smells strongly of vinegar during the hydrolysis. Once the 30 minutes are up, I pour everything into a beaker and cover the top with some plastic wrap. As you can see, as it cools down, salicylic acid crystals slowly form. Once the mixture got to room temperature, I left it in the fridge overnight to fully crystallize out the salicylic acid. In the morning, I vacuum filter off the crystals and wash them with some water to get rid of all the acetic acid. Once I washed them for a few times, I let them dry in the vacuum. I then repeated this entire process 3 more times for a total of 200 grams of acetylsalicylic acid. In the end, I was left with 144 grams of salicylic acid, which corresponds to a 94% yield. This yield is extremely good for me, and it's primarily because I used a lot of water for the hydrolysis and I let it run for an hour, which is twice the amount that was required for the procedure. And before you say that the salicylic acid is probably still wet, and that's why my yield is so high, I actually made sure it was dry by leaving it under the sun for a long time and frequently measuring its weight. The weight kept decreasing by around 1 gram per minute, and that was just the water evaporating off. At a certain point, the mass stopped decreasing. That meant that the salicylic acid was fully dry. Anyways, this is it for part 1, and in the next video, I'll be decarboxylating the salicylic acid into phenol.